This is a very fundamental, very basic matrix question. And it is asking if you have all the two by two matrices that are possible, whose entries are non-zero real numbers. Which of the following properties are satisfied? First of all, is it closed? Meaning, if you multiply two matrices that are 2 by 2, would you also get a 2 by 2? And that is correct, yes. Remember, if I had like a 5 by 7 matrix and I'm multiplying that by a 7 by 18 matrix, these two numbers have to be the same for you to be able to multiply them at all. Since they are, the outer numbers tell you the dimension of the resulting matrix. So if you multiplied a 5 by 7 times a 7 by 8, you would end up, 18, you would end up with a 5 by 18 matrix. All right, so the first one in terms of is it closed, if you multiply a 2 by 2 matrix times another 2 by 2 matrix, the internal two match, so you can multiply, and the external tell you the dimensions of the resulting matrix. So if you multiply a 2 by 2 by a 2 by 2, you end up with a 2 by 2, which is why the set of 2 by 2 matrices under multiplication is a closed set. All right, number 2, S is commutative. This is one thing that I know that Ms. Strickland has talked to you about, but matrices do not commute. In other words, if you have A times B with matrix multiplication, it does not equal B times A. All right, so we know right away part 2 is not true. Lastly, S contains an identity. Remember, an identity matrix is one such that the main diagonal from left to right in the direction that you read is 1 and the other entries are 0. If I multiplied any matrix 5, 3, 2, 7 times that, I would end up with that same matrix back again, which is what makes this an identity matrix. Initially, when I first read that, I thought, yes, there is a 2 by 2 identity matrix. However, there was an additional qualifier. The entries have to be non-zero real numbers. Well, if you take zeros out of the equation, then no. If you can't have zeros, then you don't have an identity matrix, which means part 3 is false as well. So what's true about this? Only one, which is B.